We will see another problem on DC series motor. Here the problem statement is a DC series motor hosts a load at 6 meters per second while taking 60 amperes at 600 volts from DC mains. The total resistance of the motor is 0.5 ohms. Calculate the resistance to be added in the motor circuit in order to slow the hoisting speed from 6 meters per second to 4 meters per second. Assume no magnetic saturation. Here the key points are series motor and taking 60 amperes at 600 volts. Resistance is 0.5 ohm. External resistance. What is the external resistance we need to add? That we need to calculate, and which is nothing but that is dynamic braking, right? We are adding some external resistance. Why we are adding some external resistance? To slow down the speed from 6 meters per second to 4 meters per second. Initial speed is 6 meters per second. The desired speed is 4 meters per second. So here from the given data, always we need to find out the back EMF. If you are able to find out the back EMF, first find out the back EMF. So from the given data, or what is the back EMF equation? EB is equal V minus IA into RA. From the given data, the voltage 600 volts we know, minus current 60 amperes current, 600 volts, and resistance is 0.5. So from that we can get 600 minus 60 into 0.5 will get the back EMF as 570 volts. So as it involves the speed, so here I have considered force. Another equation is force is equal to mg. Simply force is equal to mg, or weight into gravitational constant, right? Mg. So here weight m consider that weight m is, or weight is considered as k in kgs, that need to be lifted up under steady state operation. So here instead of m, here I will consider as k. So for that, the electromechanical power developed, here electromechanical power developed and power required to lift the load. So here both are same, right? So if we want to lift upward direction, or for example the power required to lift up the load, which should be equal to the electromechanical power developed. The electromechanical power developed already we can find out by using the electrical equations like EB. Already we calculated the EB. Now EB into IA, armature current, will give the electromechanical power developed, which should be equal to the power required to lift up the load. So the power is nothing but power P is equal to, in terms of speed, power P is equal to F into V, but where F is equal to mg. So here m I have considered k. So here F is equal to k into gravitational force, we know that is 9.81. So 9.81 k will become the force. That force into velocity will give the power. That force into velocity, which is equal to the EB into IA. From here, if we take EB into IA, from the given data already we calculated the EB, which is equal to 570 into current 60. Now the force is nothing but gravitational force, the gravitational constant into corresponding weight. Weight is equal to k into 9.81 k into corresponding velocity. We need to reduce the speed from 6 meters per second to 4 meters per second. Initial velocity is 6, that's why here 6. So 570 into 60 is equal 9.81 into k into 6. So from here we got one equation. Now we need to bring down the speed of 6 meters per second to 4 meters per second. It means how much external resistance need to be added. So already with the initial parameters we calculated the EB. Now EB will become, let us assume that REXT is the resistance to slow down the speed of the drive or speed of the motor. Now the back EMF, because you are adding some external resistance, means again the back EMF will change. EB is equal to V minus IA into RA plus we are adding some external resistance. That external resistance is R external. EB is equal to V minus IA into RA plus R external. So here once if you know the EB into IA, this EB into IA again 60. EB into IA will give the electromechanical power developed, which should be equal to the power required to lift up the load. The corresponding speed here has changed from 6 to 4. Now again K into 9.81 into 4. Instead of in this equation, instead of 6, 4. Instead of 570, new back EMF. Okay, the new back EMF has come by adding some external resistance. Now with this you got another equation, second equation, right? Both equations, if you divide the first equation second equation by first equation, then 600 minus 60 into 60 of 0.5 plus R external into 60 is divided by 60 into 570. On the right side, 9.81K into 4 is divided by 9.81K into 6. So here without knowing the load weight, it is without knowing the mass of the weight or load, mass of the load, we can, because these are getting cancelled, right? Simply these are getting cancelled. Hence only one unknown parameter, that is R external parameter. R external can be calculated. R external is equal to 3.167 ohms. We need to add 3.167 ohms in series with the armature resistance to slow down the speed from 6 meters per second to 4 meters per second. So in the problem statement, that's what they have asked. Calculate the resistance to be added in the motor circuit in order to slow down the hoisting speed from 6 meters per second to 4 meters per second. So that is equal to the 3.167 ohms. Thank you.